Okay, good afternoon, everybody, and welcome to the very first Access Habitable Planet Hangout with a Scientist of 2025. I'm really excited to see so many people logging in and to see the bright faces of our panel here today. Um, as you have all should know by now, because I've been talking to you for 3 weeks and you've seen 2 lectures by me, hopefully by now. My name's Dr. Carl Palmer. I'm from the Access program based in Cape Town. I am not in Cape Town today. I am on travels around South Africa, and I bumped into a little bit of a roadblock that where I am today has no electricity. So in a quite irregular turn of events, I am speaking to you from a hospital cafe because this was the only place locally that had internet and had electricity. But I've just about got enough electricity and enough time, and I hope it's quiet enough. It's quite noisy here, just to be able to come in and say welcome to the event. I'm going to be replaced as chair by the absolutely fabulous Vida Sava. I will give the chair and our panel a chance to just quickly introduce themselves in a minute. Before I pass on to them to do that, I just wanted to say a quick couple of words about our Hangout with the Scientists. I want to say to all of the students present, the Hangout with the Scientist is the part where you actually get to speak. That's what we'd really like to do, and you get to interact with our scientists. You spend a lot of time on the online course watching us speak, watching recorded videos. This is one of the few sessions where you actually get to interact with us live. So whereas the chair will ask some starter questions to start discussions, and we'll hear a little bit from the panel to introduce themselves, I really hope that we see those hands going up and we get questions from you. Any questions that you have are perfectly good for this, right? We'd like to hear what you thought about the course, what questions that you have for Duncan and Pusaletso about the material on the course, but also any questions are allowed. Questions about what it's like to be a scientist, what it's like at their university, or just what it's like to be Pusaletso or Duncan. This is your chance to ask what you would like to ask. Great. So with that, I really hope you do get those hands up. You do ask those questions. I am going to hand over to the fabulous chair for today, Vida Sava, to introduce herself and the team. Take it away, Vida Sava.
Thank you so much, Dr. Carl. Hello, everybody. Welcome to today's session. Let's make it one for the books. If you've got any questions, please remember to raise your hands and ask, and we shall take it from there. So as Dr. Carl introduced me as my full name, you guys can call me Vida for short, just to make it a little bit easier. And I'm from UJ. I'm completing my master's degree now and hopefully applying for a PhD. Let's see what opportunities come first. I'm studying a MSc in biodiversity conservation, and yeah, my project focuses on genetics and genomics, but yeah, I look at cave systems and I evaluate what animal life is found in our groundwaters using cave water specifically and sediment samples as well. But you can ask questions after everything if there's anything you're keen to know. With our panel today, we've got Mr. Duncan Kokopane and Ms. Pusiletso Masia, and I'd like to welcome them and have them do a brief introduction. Duncan, can you go ahead? And then Pusiletso follow. And then I'll take over from there.
Okay, perfect. Thanks, Vida. Hi, Planeteers. My name is Duncan. We've already met. I believe all of you watched the video already on the online course. Excuse me. I'm currently a teacher, a geography teacher specifically at Cape Town High School, and simultaneously completing my honors with the University of Johannesburg. Yeah, and that's me. You'll ask me some questions along as we proceed with our meeting. Cheers. Who say you can go in?
Hello, everyone. I hope I'm audible. Am I audible? Okay, my name is Puseletso Masia. I am the girl behind Circulating Oceans from the YouTube video. And I'm currently doing my master's at the University of Pretoria, and my studies about dynamic meteorology. Basically, I'm looking at the chaos in the atmosphere. So yeah, I'll be open to questions because I do love questions, and it's really nice to meet all of you.
Thank you, Pusiletso. To help us kick off the session, does anybody have any burning questions they'd like to ask our panel first before we go into each person's discussion? Please raise your hands if you do. Okay. If not, I think let's get this started with a question that I actually have, and then maybe that might get you guys a bit more primed to ask the questions that you might have. I'm going to start with Duncan. Okay, Duncan, your lecture highlighted the limitations of the three-cell model, such as the influence of topography and the heat capacity of land versus oceans, right? What do you think is the biggest challenge in developing more accurate climate models, and how do you approach these challenges in your own research?
Thanks for the question, Vida. Well, I think developing accurate climate models isn't as sorry, I have a sore throat. Sorry for that. I think developing accurate climate models isn't as straightforward as it may seem initially. That is because climate is affected by various factors, from ocean currents to land surfaces. And then to answer your question, I would basically say that the biggest challenge is representing small scale processes, that is wind and soil moisture, which can strongly affect global patterns, right? So I think you said something like how I deal with this problem in my research. So basically, my research, I'm focusing on testing radar data, satellite data, by calibrating it with LiDAR data. I'm focusing specifically on forest fires. My case study is in Knysna in the Western Cape. So how I do this is that I use satellite tools such as LiDAR ranging and radar to capture these local changes, such as rainfall, cloud formation, and improve the readability of climate projections. So I think that's how I kind of deal with it in my own research.
That's super interesting, and how you can relate what you've learned in the program to what you're actually doing. That's really cool, at least from my opinion. I'm going to ask one more question and then I'm going to ask the audience. Come on, guys, let's have that popcorn fire and ask anything that you might have burning on your mind to ask, either if it's related to the course that you're doing now and the lectures that you're going to do and about to do. Anything that pops up in your mind. So I'm going to go for question 2, Duncan, because I'm super curious about this. Given that you mentioned the Intertropical Convergence Zone, the ITCZ, right, affects seasonal rainfall patterns in South Africa. Could you elaborate on how a changing global climate might impact this ITCZ's position and in turn affect the region's weather and agriculture?
So that's a very interesting question, I would say. So the ITCZ, we know, as I've said in my talk, if you've watched the talk, the ITCZ is affected by the Earth's position with the sun. So if the Earth is in line with the sun at 30 degrees Celsius northward, the ITCZ will shift further north. And if the ITCZ is in line with the Earth, if the sun is in line with the Earth at 30 degrees south, the ITCZ would shift further south. So having had said that, I think we have someone with the mic on. Okay, perfect. So having has said that a global changing climate would affect the ITCZ by making its movement less predictable, because we'd have more regions of the Earth more hotter or warmer than the others. So this would mean that the ITCZ may shift less than expected and it may become less variable. causing some other parts of the world to experience more or less rainfall than the others. And then if the ITCZ shifts further north, this can cause South Africa to experience droughts, and then ultimately affecting the crop production in South Africa.
Okay, super. That was quite a concise answer. I'm going to jump to the chat quickly. I see your fences got 2 questions. I'll read them out for you, or would you like me? Yeah, let me read them out for you, and you can open the chat as well, Duncan. But just for everybody's sake, Offense says, how do you ensure, I think this is in relation to the previous question though, how do you ensure accuracy in your research, as you've mentioned that climate is influenced by multiple factors? And then I will go to the 2 hands. Thank you, Dr. Carl. I do see that now, but let's do this question first, and then I will jump to Mr. 556. So let's just do it Offense's questions quickly. Okay.
So your question is, how do I ensure accuracy in my research? So basically, my research isn't much on climate. It's mostly focused on remote sensing, right? But I used multiple models to project the future climatics, and I used different tools to basically calibrate the climate of South Africa. And then there's this other program that is Windy. It's readily available. You can install it on your phone. They basically help with various climate projections in the country. I'm not sure if that answers your questions.
Okay, Offense, if you'd like more clarity, please do type in the chat, but I think that, oh, there we go, it does.
Perfect,
Thank you,
perfect,
Duncan.
perfect.
Okay, let's go to the hand. I see, I don't know the name, but hashtag 556. Please unmute yourself and let's go for the question.
Good afternoon. Is 556 audible?
Yes, loud and clear.
Okay, I'm Bongo Sikama, by the way. I just used my exam number. So this question is not only for Mr. Duncan, it's for the panel. So I have a question here regarding the core of the earth. I would like to know regarding the core of the earth, its formation. Do we think, or is there a possibility that the core of the earth could have been a formation of the heat radiated by the sun? The heat, not heat, but in terms of like the energy coming from the sun.
Can you please repeat that? I'm not sure I understand your question clear.
Okay, so we have a core in the earth, which is I think it's liquid form, if I'm not mistaken. It's lava or something. Yes, which with very high temperatures. So my question is, could the core have or occurred as a result of the sun?
Okay, I see Dr. Carl has his hand up. If anyone, did you get that? Sorry, Duncan, I think I interrupted you.
Yeah, I think he's basically asking about why the inner core of the earth has extreme temperatures. So I think that takes us back to the formation of the earth. So I think in Carl's lecture, if you watch the lecture, Dr. Carl mentioned something about the earth forming from debris of from a collision from debris, right? So a lot of debris came together and crashed into each other. And then basically from the collisions, we have heat forming, right? So as more debris collided, the heat that was trapped inside inside the core of the earth, that's basically what the result. It was trapped inside the core. It never escaped to the outside. So it's still trapped inside. I'm not sure I put that clearly, but
Superb. Thank you very much.
Perfect, perfect.
Thank you for that, Duncan. Dr. Carl, did you want to add anything to that, or are you happy?
Oh, just quickly, the heat from the core of the Earth is, as Duncan explained, very different from the heat from the sun. They're two completely separate phenomena, but we will explore how the heat from the Earth actually does have a real impact on the climate. That will be coming up, I think, next week. Yes, I think it's in next week's core talk, so that will be coming up now.
Okay, super. Thank you for that clarification. Are there any other hands or any other questions for Mr. Duncan? Raise your hands or type it into the chat. We are here to help you guys with anything you might have. Otherwise, while we wait, I shall ask you another question, Duncan. Your explanation of the atmospheric circulation started with simpler models and built up to the three-cell model, right? How important is it for young scientists to master these foundational concepts, even if they seem oversimplified sometimes, before moving on to more complex topics?
Well, for me, I believe that not even related to only circulating atmosphere, but for every topic that one wishes to study, I think it's very important to master the basic concepts because they provide a solid foundation for the later complex topics. Like in my talk, the simplified single cell or three cell circulation model provided the building blocks to how the atmosphere really works, right? They helped us understand why winds blow the way they do, and then why some places receive rainfall while some are deserts. And then once that foundation is solid in the mind of the brilliant scientist, then it becomes much easier to grasp complex topics. So I think it's very important.
I completely agree with you, and that's how you build on. Like it's kind of like building blocks, right? You build on from one to
Exactly.
another to the next to the next until you get the complex answer that you need. Okay, not seeing any hands. I see something in the chat, Moki. Can remote sensing be applied during EIA for the panel?
Hi, Moki 520. So remote sensing can be indeed applied in EIA. I assume that you mean environmental impact assessment. Is that what you mean? So remote sensing is an applied science. Yes, you can apply it into many aspects, be it climate, be it environmental impact assessment, or whatever your research interest may lie.
Yeah, I just add on to that, like completely agree with what Duncan has said. And I think the skill is really an important one for EIAs, especially when you're trying to figure out like what's happening with the vegetation or what's happening with the freshwater system around, or like there's different aspects that you can apply it to. Hey, Duncan. Okay. I see. Sure, we are pumping up into the chat here. So I'm going to go to Andile. What initiatives are being implemented to support community need or development in our district? I will jump back to Offense's question just now. Sorry, I missed that one.
Pardon, can you repeat the last question?
Sure, I'll go for it again. What initiatives are being implemented to support community need or development in our district?
Can you please clarify your question, Andil, in what aspect? Please, I don't think it's very clear.
Andile, if you can unmute and just clarify your question. Hey, Andile, I'm not hearing from you. If you are unmuted, I think let's jump to the next question. We'll go back at least one question. Offense asked, out of curiosity, how is it being a teacher with new introduction system? I'm not certain what this means. Duncan, do you have clarity?
Well, being a teacher is kind of stressful, I would say. It's not really a career that you'd wish to follow if you're not passionate about teaching. But for me, it's enjoyable. But it sort of brings a bit of chaos in the classroom because learners do whatever that they wish, and so on. Yeah. But overall, it's nice. It's brilliant. You should try teaching as well.
Oh wow, I'm pretty sure it comes with its challenges as well. Let's go to a raised hand. Lungu Abongwe.
Hi, hope everyone's well. Just out of curiosity, I'm wondering, um, with the new, I'm not sure if it's new, but the artificial rain techniques that are there, either like releasing a dry ice into the atmosphere or silver iodide or something like that. What effects do those have into like the climate, or rather, do they affect the remote sensing and everything that's there, which you usually use to like monitor the natural environment? Now I'm wondering, do these artificial substances influence the results, or it's the same?
Duncan, do you have an idea?
I wasn't paying attention. Can you please repeat that?
Please go again, Abongwe.
Okay, that's
Sorry.
not a problem. It was a question on the topic of artificial rain. So,
Okay.
with the artificial rain, whereby they either release dry ice into the atmosphere to influence rain. Either they even release this, I think it's silver iodide or something along those lines. So with that technology that's being used now, what influences, or rather, does it influence in how you monitor the remote sensing or the GIS or like the environment? Like, what effects does it have on the natural, on the nature, or rather, the natural way of doing things? I'm assuming that you monitor the environment based on the natural occurrence of things. So now with this artificial way of inducing things that are meant to be naturally occurring, does it influence in any way, either positive or negative, or what's your take on that?
Okay. I think your question is sorry, is much clearer now. When it comes to remote sensing, we use different tools, as I've said earlier. So it basically depends on the type of tool that you use. So if you would use optical remote sensing, that's something basically like a camera that you use to capture data on the surface, it would negatively impact my data capturing because it would obstruct the view of the satellite, right? But if I use something like radio remote sensing, radar is able to do to penetrate through weather. So whether we have cloud that's either artificially induced or natural clouds, it doesn't really affect my data capturing when I use radar.
That's quite a detailed answer. Does that answer it for you, Abongwe?
For now, yes.
I think you could have a way more detailed discussion, and I'm sure Duncan would be open to answering that even off the platform. Just taking note of the time. I think I'm going to let Nkateko ask a question, and then we'll do one or two more from the chat, and then let's get Pussy Letso involved. Shay, man, look at her looking at me like, girl. Okay, Nkateko, go for it.
Hello everyone, I hope you can hear me. Out of curiosity, I would like to know how the Coriolis force affect or influence the different seasons that are experienced in different hemispheres.
Did you get that, Duncan? I think she needs
Can you
to
can you
speak
please type
closer.
in the chat or speak closer and a bit louder if you can?
Can you hear me now? Okay, I would like to know how the Coriolis force affect the different or influence the different seasons that are experienced in the different hemispheres.
Okay, so I'm not sure if you carefully looked at my talk because I never said the Coriolis force affects the seasons, but I get and I understand your question. So what I said was the Coriolis force breaks the single cell circulation model into the 3-cell circulation model, right? So the seasons, to answer your question, the seasons in different hemisphere have to do with the Earth's tilt and position to the sun. So if the northern hemisphere is tilted towards the sun, it experiences summer, and the southern hemisphere that would be tilted away from the sun would experience winter. And then if when the Earth revolves around the sun and then it comes back the other way, the southern hemisphere would be tilted towards the sun, experiencing summer, and the northern hemisphere would be tilted away. So that's how our revolution affects seasons.
Okay, Puseletso, do you have anything to add to that? Please go for it.
Thank you, Vida. Also, to answer your question, I feel like it does somehow contribute to the seasons, not necessarily the seasons, but the weather patterns. I mean, the Coriolis force per se, because remember the definition behind it is that it deflects wind to the left in the southern hemisphere and to the right in the northern hemisphere, right? So somewhere, somehow, it affects the weather patterns, not per se the seasons, but it can actually jump into that if you want to like dig deeper into like atmospheric dynamics. But the Coriolis effect does play a huge role in seasonality.
Definitely, definitely.
Super. Thank you for that, Puseletso. I think I'm going to go to one question in the chat and then a question from, I think it's Moki. And then I think we're going to just ask Duncan one more question, 3 questions, Duncan, and then we'll move over. So the question from Ompa Malakano. Can you please explain what climate models are in full detail and what is their role or how reliable they are with regards to climate change? You're muted.
So you'll learn more about models when we get to, I think, is it hot talk number 4? No, it's not 4, it's mine. I think it's 6 with DC. You'll dive deeper into what models are. They're basically mathematical representations of Earth climate system, right? So in your case, it would be for climate. So you basically use, if it's a mathematical model, you'd use equations to sort of project or predict what the future climate would be like, using past data of which we'd see as we proceed with the hot talk series. So you don't just tuck your belt and then wait for the thing.
Okay, super. Yeah, let's be patient. As excited as we are to learn and have these burning questions, which are great, keep them firing, guys. Even if we don't get to answer them now, I think we will try collate them and have Duncan and Puseletso just try their best to answer some of them. We'll organize with DC as well. All right, let's go to Moki in the participants. You have your hand up, you can unmute, and let's go ahead with your question.
Thank you, ma'am. Dunkel, I heard you talking about the optimal, which cannot penetrate the ground, and also you talked about the radar, which can penetrate the ground, and I believe it can interpret the soil profile and the rocks within the ground. So I wanna know how depth it can go to penetrate the ground.
So funny enough, my initial proposed research was based on predicting sinkholes in a mine that was in Joburg. So what I planned on doing in that research with my supervisor was basically tracking millimeter micro changes within the ground that would sort of predict where the sinkholes would occur in the mine. So indeed, your statement is correct. A radar can absolutely penetrate through the ground. I think it can go within, to the greater depths of the ground, because remember, remote sensing is also applied in mineralogy. I'm not sure if I'm pronouncing that correctly. So where they use remote sensing to penetrate, to check, or to assess the kind of minerals that are underground. So you can imagine how far deep the minerals are. So depending on the spectral signature, that's something that we can discuss some other time. We can determine what kind of minerals are underground. So to answer your question, it does go deep within underground, yes.
Fantastic. Thank you for that, Duncan. That even piqued my interest. I might have some questions for you after this. I think we have to move over to Puseletso. We will collate these questions, everybody. But yeah, just for time, we're going to move over to her talk. So she did a talk on, what was it? Circulating oceans, correct? So yeah, do we have any burning questions about circulating oceans? I do see the chat is firing up again. Let me just double check. Well, we do have a question. I think both of you can kind of go into this. Can you explain how Coriolis force effect related to Ekman spiral?
I think you're talking about the Ekman transport. So basically, remember the definition behind Coriolis effect is that, as I said, it's a force that deflects winds to the left in the winds or objects basically, winds or water to the left in the southern hemisphere and to the north to the right in the northern hemisphere. So basically, because now we're dealing with the ocean, it deflects the water. So it takes place, it helps the Ekman transport. Remember when we have upwelling, right? So it helps the Ekman transport to transport the water along shore. Yeah, that's what it does. And also, it also helps upwelling. Upwelling is a process whereby nutrients at the deep ocean are brought up to the top. So for that to happen, a force has to take place. Did I answer your question?
I think that was answered quite well, Puseletso. If Gugu has any more, she can type in the chat or raise her hand. While we wait for the fire to start cooking here, let us get on with this question that I have for you. Your lecture highlighted the connection between ocean circulation and El Nino and La Nina. Given that these events are becoming more frequent and intense, how does your research on hydrology and water resources at the University of Pretoria aim to address the impact of these climatic patterns on water availability in our country?
Thank you for the question. First of all, I'm not doing hydrology and water resources at the University of Pretoria. I did it in my honors. So now I'm dealing with, I think it was a typo by Dr. Call, it's okay. Now my research is on dynamic meteorology. So I'm looking at the chaos in the atmosphere. So basically, before I answer the question, what I do is that I look at the impact that ozone, I think we are all familiar with ozone, the impact of ozone and greenhouse gases and how they impact our southern hemisphere cut-off flows. So what cut-off flows are, they are low pressure systems that are become detached from the westerly wind. So basically these cut-off flows are responsible for our precipitation patterns like our rainfall, snow. So these are the cut-off flows that are responsible for these weather patterns in the southern hemisphere. So looking at El Nino and La Nina. So trying to link your question to what I'm doing is that El Nino and La Nina change ocean temperatures, right? So when ocean temperatures change, This also in turn, remember the ocean and the atmosphere are always chatting, right? I think Duncan also covered that. And in my talk, if you look at that, you see that I've covered the interaction between the ocean and the atmosphere. So El Nino and La Nina change ocean temperatures. So in turn, they alter large-scale circulation, large-scale atmospheric circulations. So basically meaning that they alter our large-scale atmospheric circulation systems. So cutoff flows are part of those systems. So when you alter cutoff flows, you alter potential rainfall in the southern hemisphere. So basically, my research looks at how changes in temperature, basically changes in the impact of ozone and greenhouse gases, how they affect these cutoff flows, which impact South Africa's weather or the weather in the southern hemisphere. So we're still looking at that, at how these actually change our weather. And I think I should probably, did I answer your question?
I think you answered that very, very specifically.
Yeah.
And I think you're right. We keep on building one onto the other. Like it's always kind of
it's
like a rat race, right? It's always trying to find the next part of the answer. Okay, I don't see any other questions, guys. This is your time to rise and shine and ask those burning questions with anything to do with the program, with the panelists, anything that might interest you. This is your time. So don't be scared. We don't bite, not even on Tuesdays. Even though it's not a Tuesday, let's get those questions rolling. And while we wait, I'll ask one more question. Puseletso, you described the thermohaline circulation as the Great Conveyor Belt. Can you explain the potential consequences of a disruption to this system, perhaps caused by melting polar ice, for example, on a global climate and regional weather pattern, or the patterns, let me say?
Okay, so according to my talk, so thermohaline circulation, like it's like the cousin of a great conveyor belt. Before I explain what the process is, so I think most of us have been to the airport, right? Right, we've been to the airport, and do you know that thing? It's called a carousel. I think it's called a carousel. That thing that goes like this, and then your bags, where you collect your bags. So that is how the thermohaline circulation works. It's like the great conveyor belt. So it basically collects or heat and nutrients around the globe, just like the great conveyor belt. So if it was disrupted by the melting polar ice, it will actually change the global climate patterns, right? So when it changes the global climate patterns, some areas will be very hot, some areas will be very cold, and in turn, it will probably change how we receive rainfall in South Africa, or rather in the Southern Hemisphere in general. So impacting the global climate pattern impacts precipitation patterns. Did I answer you?
Okay, guys, if your question's been answered, just give a thumbs up so we know that you're happy. And if you're not, then please just clarify what you needed more explanation on. I do see this kind of links to what Nkateko asked. Can I conclude to say that El Nino can lead to hydrological and meteorological drought in certain regions?
Yes, it can. As I said that these systems, El Nino and La Nina, they change ocean temperatures, and changing of ocean temperatures leads to changes in large-scale circulation systems. For example, cutoff flows, which are responsible for rainfall or drought in South Africa, right? So if those systems become damaged, become altered with, like, they are disturbed, we can experience droughts and or floods. Hence, we are working as researchers to actually find a way, mitigation strategies to help, like, predict, like to help policymakers and people to predict when we would experience droughts and floods, and how we can actually handle that.
I shall send you a love emoji for that because that was greatly put together. I do see we have a question. Awe, sorry if I pronounced that wrong, Molos. What are the biggest misconceptions people have about the greenhouse effect, and how can we explain it more simply?
Well, the misconception that people have about the greenhouse effect is that, I don't know, people think that it's a negative thing. When you hear the greenhouse effect, people think, okay, it's a negative thing. But um, what I can say is that in my research, I'm actually looking at how ozone and greenhouse gases, how they impact the southern hemisphere. So misconception is that people think that is the greenhouse effect is like a negative thing. Yeah, that's what I can say. Yeah.
Hey, Duncan, I see you want to add. Let's go.
Yeah. Just to add on what Puseletso said, most people really do think that the greenhouse effect it's a negative thing. When they hear of the word the
Yeah.
greenhouse effect, they become scared or something. But it isn't really the case. In fact, the greenhouse effect is a natural process which is very essential for habitability. If we didn't have the greenhouse effect, temperatures on Earth wouldn't be close to being habitable. So that means the Earth would be way too cold, as I think Danforth said in his talk.
Yeah, I think that aptly answers that. I think I'm going to jump to some of the questions in the chat and some comments. But I'll go for Nkwazi Masango. If water covers 70% of Earth, why is there still a shortage of safe drinking water in many places?
I feel like, okay, even though we have 70% of water, it doesn't mean that the water is like we can consume, is consumable. Some water is salty, we can't consume it as human beings. I think how many percent, if I do remember, Vida or Duncan,
I
that
think
is
I think we have 3% of fresh water.
Fresh water, yeah. And
then
it's in like different forms, whether that's the
Yeah,
glaciers,
sun
whether
storing
that's
glaciers in ice caps.
groundwater.
Exactly.
yeah.
Yeah.
So not water that we have is we can consume it. So yeah, I wish that was the case, but yeah.
I used to wonder that a lot. I mean, like, why do we still have water shortages while there's, 70% of water on Earth? A great question.
Yeah, that is a great question. And I mean, there's also technology that's coming out that you can desalinate water, especially in drought-heavy countries that border on the sea. That like you can desalinate the water. So there's that aspect to investigate as well. Sure. This chat is popping now. I don't see any hands, guys. We also want to hear your voices. We don't want to just hear our three voices. I'm so like, yeah, I want to hear your voices. The fresh blood coming into Access. Let's hear you. Um, yeah, I see there's whew, it's popping. I'm going to jump to Tobelani. Just curious as to how do we find readily available high resolution data for oceans, if any may recommend. I'm doing a project in detecting and monitoring offshore oil spillages. Challenging part is to find data. I think that is the most challenging part, and I'm excited about your project. Guys, panel, do you have any resources you may recommend?
Well, the data that I use is already made, unfortunately, but I use the flexible ocean climate infrastructure data from a model called the FOCI1. So it's already like collected, so I wouldn't know where you'd get the type of, because I deal with the atmosphere, not the ocean. So I'm sorry.
Duncan, any
I think you should
suggestions?
try looking at the JDI. It captures lighter data for the planet, for Earth, basically. So I think you may find some parts of the ocean, luckily, hopefully, for your study area there. Try I'll send you the link in the chat box.
Okay, and just like a side note, if you're not certain, like say for example, the resources we mentioned here are not good enough, Tobelani, just email us. We can also maybe put you in touch with people that are in oceanography or ocean-based studies, and maybe they can also help you. So that's also the great thing about the community is you can ask anyone for help, and if they know, they'll help. If they're not, then they'll pass on. Okay. I'm going to there's a hand, I think. Oh no, it's not anymore. Let's go back to the chat. I'm going to ask this question from Offense, who's on a roll. Do you think our government is doing enough in supporting you guys in your research, looking at how climate change is an issue that needs immediate action?
Well, speaking from experience, yeah, I feel like the government is doing, yeah. I mean, we do get funded for research, obviously. We have all the materials, everything that is we need, we get so to conduct our research. So I don't know if you're speaking in terms of what, but I feel like as a postgrad student, you obviously when you conduct research, your supervisors make sure that you have enough resources to conduct your research. And yeah, I feel like we do have enough. Yeah. I'm not sure about Duncan and Vida.
Duncan, anything you'd like to add?
Now definitely get enough resources, as Puselisa said. So I concur.
I think for me, it's about knowing where to find the resources and looking deeper than what your Google search sometimes allows, and asking the people around you, looking for the right mentors and supervisors that have the resources for you. But for me, it can be improved. I'm not going to go into politics or anything like that, but with anything in life, you can always do better. So I do think, yeah, we could do better. We could have more. Um, but yeah, I'm going to leave it there. Sure, this chat is on fire. Someone from Planet Venus has joined us. Welcome, TN. So nice to have you. I hope the atmosphere is to your liking here. Number 556. I'm going to ask your question. Okay, water occurs in different states, solid, liquid, and gas. So that's 70%.
Oh, sorry.
Oh, that's not
Just
a
a
question,
remark
that's
on
a
one of the
comment.
questions.
Sorry, say again.
Yes, as you've said, it's just a comment on one of the questions that were asked regarding why are we having a shortage of water.
I'm just reading through it thoroughly now, and I agree with you. There's a comment. Apologies. Let's go to Molos. Which greenhouse gas is the hardest to control, and what makes it so difficult compared to others? Sure, control. Okay.
I think I'm not sure. I'm not gonna lie, but chlorofluorocarbons. Either chlorofluorocarbons because remember they come from the emissions from factories, the burning of.
So sorry, Pustiletso, can you just pause? Can we all mute ourselves just to make sure that we can hear Pustiletso?
I
Thank
feel like
you.
it's the most difficult gas to control because no matter even if we implement Montreal protocols to say that we should be environmentally friendly, it will always be there because we need factories, right? And yeah, Duncan?
Yeah, just to add what on Puselitsa said, the hardest gas that's to get rid of, it's also carbon dioxide, I would say. Because I think while other greenhouse gases have shorter lifespan, carbon dioxide survives for like 200 years in the atmosphere. So once it gets emitted into the atmosphere, it's really hard to get rid of it. And then there are very multiple sources that emit carbon dioxide into the atmosphere, like riding your car or bus or the production of electricity, power plants, and so on.
Okay, yes, I think that is the answer. Carbon dioxide is definitely the one that we should be worried about. Pusiletso, I'm going to ask you a question because I don't see any hands. Come on, guys, we've got a few more minutes. Let's utilize them to the best of our ability. We've got two specialists available here that are ready and willing to answer any questions you may have. Remember, it doesn't have to necessarily be about the content. It can be about their journeys. It can be about the access program. Utilize this time. Okay, while we wait, I shall ask another question about your journey, Pusiletso. As a core lecturer for the circulating oceans, right? And a Limpopo representative for the PRC, which you'll have to explain what it is. What have you learned about effective science communication and leadership, and how do you apply these skills in your daily life and research?
Thank you for the question, Vida. Okay, let me explain what the PRC is first. So the PRC is like basically the can I say the mother of HPW? Yeah, it's basically the provincial representative committees that make sure that almost everything moves smoothly in terms of not per se workshops, but behind closed doors. So to answer your question is that I've learned that when you, as a co-lecturer, when you attain knowledge, remember when I started, I didn't know anything about circulating oceans. So I attained that knowledge. So I made it a point that after attaining the knowledge, I will make it accessible to everyone, right? Make it relevant to everyone and take action to make it available to everyone. So that was my go as a co-lecturer, not to keep the knowledge to myself, but to share it to other Planeteers. So as a leader, PRC leader, um, I practiced what is called efficient communication. We communicate as leaders in a respectful way. Collaboration, you have to learn how to lead by example. So all of that, I've taken it into my daily routine and in my research work by I can communicate with other people from different disciples. I can communicate with my lecturer. You are able to present properly and efficiently. And yeah, man, yeah, there's a lot. I mean, there's a lot. You gain information, you can make it accessible to other people through research. So yeah.
I agree. And it's also about the soft skills, not just these hard skills in theory that you're learning now in the online course. There's other things that you learn as you go along the process, and communication is one of them. And we always like underestimate the importance and nuance. Like that's a big word, I know, but the nuance and the specificity of what communication can do in a situation. I'm going to go to a question in the chat and then to Muchidisi. First from Reneth, do you think we have low shortage of water or poor management of water?
Um, I think, well, it can't be low shortage of water, but poor management. I feel like we do have enough water. I don't know, Vida. What do you think?
I'm going to
Personally,
disagree with you. So I agree with you on the poor management, but I'm also going to disagree with you on saying that we have enough water. I think we are a very water scarce country. So yeah, I don't think we have enough water. We are, I was going to say importing, listen to me, we are getting a lot of water from Lesotho, from the Highlands Project, and also from Mozambique. So that's not even our water if you want to consider boundaries, our South African border boundary in this. But yeah, I think we need to really work on managing this very scarce resource. So I'll agree with you on that. Duncan, would you like to add on anything to this?
Now I'm okay. I was just saying maybe it's a little bit of both.
Yeah.
Absolutely. Absolutely. Okay, and then I see, let's go to Muchidisi. Please unmute.
Good afternoon, guys. Mine was a question, just a follow up on in terms of what Duncan has said in the first answer. It was on the chart, and so I asked in terms of like how can soil moisture contribute to climate change?
Oh, okay. Thank you for the question. More, I can't see your name. Sorry. Okay, thank you for the question. So what I said initially was that soil moisture can basically contribute to global heat, right? So remember, soil has the ability to capture water, right? So it means that when a soil has a lot of high moisture content, it would basically evaporate, and then evaporation leads to condensation and then enforcing rainfall. While drier soils may not have the ability to evaporate, and then therefore it means that places that have high soil moisture content will have less hotter temperatures compared to places that have drier soil.
Okay, I think that is it in a nutshell, Duncan. Thank you for that. I'm going to ask Masebe a question in the chat. Do you guys have any knowledge of agricultural practices that contribute to the greenhouse effect in a negative way, affecting climate change?
Apu said, "Do you want to go?"
No, you can go.
Okay. I'm not really well knowledgeable on agricultural practices, but one thing for sure that I can run to is deforestation. Definitely. So we know that I think in my grade 9 natural sciences, I've learned that trees have the ability to capture and store carbon dioxide from the atmosphere. So basically removing those trees means inability to capture more carbon dioxide, and eventually the CO2 accumulates in the atmosphere and basically leading to climate change and global warming. So I think maybe that's part of agricultural practice. And also I think but I'm not sure about this one, the use of fertilizers. I'll look into that.
Definitely. And then I think let's go to Tapelo as our last question for the day. Just checking our time. Tapelo, please go for it.
Good afternoon, colleagues. I have an answer to that question actually. Yes, I'm a BSc graduate at the University of Mpumalanga, and I majored on geography and water resource management. So most of the issues around climate change, they were part of my modules, and we've been writing about it more and more and more. In a nutshell, so some few challenges around agriculture is actually livestock production produces a lot of methane. Your cows, your sheep, your goats, and pigs as well. You know, pigs, they are a different type of animal that just prefers a different type of atmosphere. So it's never clean where you always find pigs, you know. So that contributes to climate change. And also rice cultivation. I remember one of the students. So it's that rice actually flooded rice actually creates anaerobic conditions that release large amounts of methane as well. So as well as the part of fertilizer usage, it also leads to excessive use of nitrogen-based fertilizers, increasing more nitrogen nutrients. Yes. So more excess of the nitrogen nutrients creates more some sort of what's this word? What's this word? You know the English word when they say more of a thing is dangerous. Yeah, it creates something like it creates consequences to some parts of the food chain and the environment as well. So those are the major concerns. They're always based around the livestock and excessive use of some nutrients found in some of the areas. Thank you.
Thank you for that, Tapelo. I think it does add a layer of complexity to this question that we've been trying to answer. I am aware of time, so I think with all the extra questions and comments that we have in the chat, please don't lose them. Please do type them out, and I'm sure Duncan and Puseletso will get to you with answering that, or even Dr. Carl once he's seen the recording. But with that, I think our time is up, ladies and gentlemen. An hour goes by so quickly. So thank you for your time. Thank you for your curiosity, the most important part. And I wish you all the best with the continuation of the course, and maybe we see some fresh new faces. Good luck and goodbye, everybody.
Bye. I hope to see you in December, everyone.